Yes, hello again. Multiplying polynomials. This is Math 111, section 5.4. Today we're going to talk about multiplying polynomials. Now that polynomials have been well defined and we've got some experience in adding and subtracting and evaluating polynomial expressions, now we're going to go up the ladder and talk about multiplying polynomials. Again, we are going to start out with the simplest case, a monomial times monomial, and build our way up to more complicated problems, as we'll see. Alright, monomial times monomial. What's this all about? Well, if I take a simple monomial, say 3x squared, and multiply it by 6x cubed, I'm betting that most of us already know what to do. We just apply our associative law of multiplication and rules for exponents. In particular, we'll multiply the coefficients here first. We can do that because multiplication is associative. In other words, if I have a string of products, I can multiply the numbers together first and the variables together second and multiply the result, right? So the coefficients multiplied gives me 18. The variable portions multiplied gives me x to the 5th power. So to multiply two monomials, I basically apply my rules for exponents as learned in section 5.1. Let's get something a little nastier. 2a cubed bc times 7ab squared c times minus 12ab c to the 4th power. Here I've got a string of 3 monomials being multiplied, and of course I can apply my associative law and commutative law of multiplication, meaning in a string of factors being multiplied, I can multiply any 2 or 3 that I like at any time. In particular here, what I will do is multiply the coefficients first and get a result. 2 times 7 times minus 12 is going to be minus 168. If I look then at my powers of a, I'll have an a cubed times an a times an a. That'll give me a to the 5th power, 5 factors of a in my result. What about powers of b? I can multiply a b times a b squared times a b. That'll give me b to the 4th power, 4 factors of b in my final expression. And factors of c, I have a c times a c times a c to the 4th power. That gives me 6 factors of c, or c to the 6th power, in my final return. Alright, so multiplying monomials times monomials, hopefully not a big deal, and basically depends on our understanding of rules for exponents. Up the ladder we go. Monomial times now a binomial. I'll give you a simple example of that. 3x squared times 6x to the 6th plus 4x squared. Alright, of course, to multiply a monomial times a binomial, as you might guess, we're going to apply our distributive law, basically multiply each term in that binomial by 3x squared, and use our rules for exponents to simplify. Alright, 3x squared times 6x to the 6th, I'll multiply that first. I get 18 x to the 8th power. Then to that I will add 3x squared times 4x squared, gives me 12 x to the 4th. Alright, now this is my final answer. Beware, these are not like terms. Remember, like terms are terms where the coefficients may differ, but the variable portions and exponents are the same. Alright, so these exponents certainly are not the same, so these are unlike terms. So we can note that can't combine unlike terms. So this is as simple as I can get, and this is my final response for this particular problem. Alright, monomial times a binomial. How about a monomial times a trinomial? Well, as you might guess, we're going to apply similar principle here. Let's start out with give me one here, 2 minus 2ab squared times 3a cubed b minus 2a squared b plus 4b squared. Alright, and essentially the same process, except instead of distributing over a binomial, here I'm distributing over a trinomial. In other words, I'll take this minus 2ab squared monomial and multiply it independently by each of the three terms in the trinomial, applying my distributive law. Let me see if I can do this in my head. I'm going to multiply minus 2ab squared times 3a cubed b, so I'll get a minus 6a to the fourth times b cubed, multiplying this first product here. Alright, now I'll worry about the second product here. Minus 2ab squared times minus 2ab squared. Minus 2ab squared times minus 2a squared b will give me a positive 4. And a times a squared is a cubed. And b squared times b is b cubed. So that'll give me the second term. Second product in that string. And how about the third one here? Minus 2ab squared times 4b squared. That'll give me a minus 8a b to the fourth power. Okay? Alright, now let me check. Are any of these like terms? No, they are not. Alright, they're all different. Well, all the variables are the same, but the powers of those variables are different. So all three of these terms in my answer are unlike terms, cannot be combined. So I call this my final answer in my monomial times trinomial example. Alright, I can think you can see as we go up the ladder here, if we take a monomial times any number of terms in a polynomial, we work it out as above. In the above two examples, basically I apply my distributive law and of course rules for exponents as discussed previously in section 5.1. Alright, so I'm going to assume that we know how to multiply a polynomial by a monomial and go up the ladder. What's next then? A binomial times a binomial, I think, would be next up the ladder in degree of difficulty. Oh, for example, we'll start out easy. 2x plus 3 times 3x plus 2. This is a binomial times a binomial, and as you may recall from your first course in algebra, to multiply binomials we apply what we call the FOIL method. Basically, we multiply the firsts and the outers. Multiply the first product, then multiply the outer product, then the inner product, and the lasts, and add up those four products. Alright, so if I multiply the firsts, I get 6x squared plus the outer product gives me a 4x plus the inner product gives me a 9x plus the last product gives me a 6. Alright, let me check that. 6x squared plus 4x plus 9x plus 6. Alright, please note that often, but not always, the inner and the outer product are like terms and hence must be combined to get a completely simplified answer. So, of course, the 6x squared term has to stand alone. 9x plus 4x is 13x, and the constant term also sits alone. So when I multiply these two binomials, I end up with a degree 2 trinomial according to my FOIL method. Alright, let's try another one a little harder. If I ask to multiply 7y squared minus 4 times 2y squared minus 1. Well, this is a degree 2 binomial times a degree 2 binomial, and to multiply binomials we apply the FOIL method. First product, 14y to the fourth. Outer product, be careful of the sign, minus 7y squared. Inner product, minus 8y squared. And the last product, be careful of the signs, is going to be positive 4. And again, we can see these are like terms. Like terms can be combined by adding or subtracting the coefficients as indicated. So I'll end up with 14y to the fourth minus 15y squared plus 4. This is my final, completely simplified answer for this binomial product. Okay. All right, let's try one that'll leave it a little harder. If I ask to multiply 4x cubed y plus 5, this one's a little nastier. Give me a minute here. 2 times 2x squared minus 3y. So I'm asked to multiply a degree 4 binomial times a degree 2 binomial, and anytime you're asked to multiply binomials, we'll apply the FOIL method. Alright, so let's talk about the first product. That'll be 8 x to the fifth y. What about the outer product? That'll give me a minus 12 x cubed y squared. How about the inner product? That'll give me a plus 10 x squared. And then the last product will give me a minus 15y. Alright, so this binomial has, of course, more than one variable. Sometimes binomials, just like any polynomial, could have more than one variable, but the principle remains the same. None of these are like terms. Notice the variable portions look different in all 4 of these terms. That means they are unlike terms. They can't be combined. So this would be my final return. This is going to be return a 4-term polynomial of degree 6. 4-term polynomial of degree 6. Alright, so we've multiplied 2 kind of nasty looking binomials. Let's try another one involving some fractions here. 10w minus 1/5, a fraction, times 5w plus 3/10. Alright, again, a binomial product calls for the FOIL technique. First product, 50w squared. Outer product, well, what's 10w times 3/10? Of course, the 10s will cross cancel, and I'll end up with a 3w for my outer product. Okay? Inner product, minus 1/5 times 5w. Now, what's minus 1/5 times 5w? Of course, the 5's cross cancel, I end up with a negative w. And the last product, minus 1/5 times 3/10. Well, minus 1/5 times 3/10, nothing cross cancels, so I'll just have to multiply across. I'll get minus 3 over 50, and that can't be reduced. That's already in simplest terms, so I would leave my constant term as a minus 3/50. Notice, the inner and outer product here are like terms. That happens often, but not always. So, combining the outer and inner product, I'll get 50w squared plus 2w minus 3/50. And that is my return for that binomial product. Alright, so we gave you 3 examples of the FOIL technique. We can still go even further. A binomial times a trinomial expression. Well, how do we handle something like that? Again, we'll start out easy in this genre. This is a binomial times a trinomial. Alright, essentially what you have to do is multiply each term in the trinomial by each term in the binomial, and then combine like terms as needed. Here's how I like to denote it. First thing I'll do is distribute every term in that trinomial by 2a. In other words, distribute the 2a factor across the trinomial and then play the same game with that second term in the binomial. Multiply each term in the trinomial by b. And what I'll do is line up these intermediate products in like term columns. Let me say that again. I'm going to arrange the like term products in columns that will be easy to combine. Let me show you what I mean. I'm going to take everything here in this trinomial, multiply it by 2a. I'll get 6a cubed minus 8a squared b minus 2b cubed. Hang on a minute. One mistake. Try it again. Multiplying everything in this trinomial here by 2a. I'll get 6a cubed minus 8a squared b, and then 2a times minus b squared is minus 2ab squared. So please correct that error. Now that I've multiplied through by 2a, I'm going to multiply everything through by positive b and arrange like terms in columns so they'll be easier to combine. b times 3a is going to be 3a squared b positive. Next, b times minus 4ab squared is going to give me a minus 4ab squared. So notice I line up those terms in the a squared b columns. And finally, b times minus b squared is minus b cubed. Alright, so if I play my housekeeping right, everything is nice and neat. All like terms are arranged in columns, making them easier to combine. Adding now, I get 6a cubed minus 8a squared b plus 3a squared b is going to be a minus 5a squared b. Minus 2ab squared minus 4ab squared is minus 6ab squared. And no other b cubed term. So minus b cubed is going to be my final term there. Alright, notice there are no other like terms here. None of these terms can be combined. So my final return for this binomial times trinomial product is a degree 3 4-term polynomial. Alright, let's do another one. Binomial times trinomial. Oh, let me get a fresh screen. Alright. Binomial times trinomial. Alright, the book talks about a vertical form, which I suppose is okay. I'm not too crazy about it. If you want to use it, that's fine. Vertical form is talked about, let's see. Vertical form is in pages 438 to 439. I put it in the assigned reading. You don't have to use it if you don't want to. I'm going to go ahead and work this out like I just did the previous one. Binomial times trinomial. Well, basically multiply the trinomial through by each term in the binomial and then add the resulting products according to your like term principles. Alright, first thing that we're going to do is multiply everything through by 2x. So I'll get 6x cubed. Alright. And now 2x times 2x is going to be plus 4x squared. And then 2x times minus 5 is going to be minus 10x. Alright, that multiplies everything through by 2x. Now I'll multiply everything through by 1 and arrange the resulting products in like term columns. Alright, so 1 times 3x squared is 3x squared. hence making an x squared column to add later. 1 times 2x is going to be 2x, making an x column of like terms to add later. And then 1 times minus 5 is, of course, minus 5. Alright, so I'll combine all these intermediate products. And some of these terms are like terms to other terms, some are not. Alright, 6x cubed doesn't combine with anything. 4x squared plus 3x squared is 7x squared. Minus 10x plus 2x is minus 8x. And minus 5, of course, stands alone. So there's my result for this binomial times trinomial product. 6x cubed plus 7x squared minus 8x minus 5. The result is a degree 3 4-term polynomial. Alright, one more type of product I want to talk about here. Oh, hang on a minute. A little trouble there. How about when we are asked to multiply 3 polynomials? Now, let me give you an example here. I've got a monomial times a binomial times yet another binomial. Alright, as we know, multiplication is commutative, multiplication is associative. What that means is I can really multiply these in any order I like. Alright, what I'm going to do to minimize the ink involved, I'm going to multiply the binomials first. That'll give me a, looks like a trinomial, which then I can, I'll just have to apply that 5CD factor across just once. Let me show you what I mean. Alright, let me see if I can do this in my head. I'm going to multiply this binomial product first. I'll get 3c squared for my first product. The outer product is going to be minus 8cd. The inner product is going to be plus 10cd. I'm sorry, let me try that again. The outer product is going to be minus 8cd. The inner product is going to be 18cd. So notice the outer and inner products add up to a 10, positive 10cd. So I'll put that there. And then my last product is going to be a minus 48d squared. Okay, so I successfully multiplied the 2 binomials, and don't forget you've got to multiply that through by the monomial 5cd. So basically I apply my distributive law, multiplying through here. I'll get a 15c cubed d plus 50c squared d squared, and let's see, 5 times 48, I believe that's minus 240 c d cubed. Applying my rules for exponents as needed. So your final response, 15c cubed d plus 50c squared d squared minus 240 c d cubed. So multiplying those 3 polynomials, I get a trinomial of degree 4. This is a degree 4 trinomial. One last one I want to do today. This is more or less from your homework list. This is example or exercise 102 on page 446. And somewhat similar to the previous problem. Let me write it down first. It is a little nasty looking. Alright, 1/3 a squared b cubed times 3a cubed plus b to the fourth times minus 6b. Alright, what do you want to do here first? Well, I suppose it's sometimes a matter of taste. Again, I like to try to pick the easiest way out here. I'll notice if I multiply these two monomials first, I may get something a little simpler looking. Namely, I'll end up eliminating that fraction, and then I can multiply that perhaps simplified monomial times the binomial in the second step. So I'm going to multiply monomials here first. I suppose what you do first depends on the problem you're attacking. If I multiply a third a squared b cubed times minus 6b, that'll give me a minus 2 a squared b to the fourth. Okay? Then I can take that result according to my associative law and multiply by the third factor in the chain. Alright, so minus 2a squared b to the fourth times 3a cubed plus b to the fourth. Again, I got to apply my distributive law here. Multiply through this binomial by minus 2a squared b to the fourth. I get minus 6 a to the fifth b to the fourth. Be careful, it's so easy to make a mistake. And then minus 2a squared b to the fourth times b to the fourth gives me minus 2 a squared b to the eighth. Oh, I almost made a mistake. Look at that. B to the fourth times b to the fourth is b to the eighth. I almost called it b to the sixth. Let me check it again. Minus 2a squared b to the fourth times 3a cubed. It's going to be minus 6 a to the fifth b to the fourth. That looks all right. And now the same monomial times b to the fourth minus 2 a squared b to the eighth. Looks good. So there's my return for this 3 polynomial product. Alright, so I'll call it a day. It's about 27-minute point, and this concludes Math 111 section 5.4, multiplying polynomials.